Hi everyone, welcome back to our channel. So Shomu sir, any interesting question today?
Yeah, I would definitely say interesting. Escalator-based problem, very basic idea, but then it has been indicated in a way that people might get confused.
Okay.
So whenever you have an escalator-based problem, there's a basic idea that you have to understand. So suppose this is the escalator. I'm just drawing this part that is not relevant. So these are the steps of the escalator. Suppose so this is where you are climbing the escalator. Whenever there's an escalator which is moving, and you are also walking on it. So what I mean by you are also walking on it is you're not on one step. So you're walking on the escalator while it is moving, something like that. So there are two things that can happen. One is whichever direction the escalator moves, you also move along with it. So in that case, however number of steps you have moved, plus whatever number of steps the escalator has pushed you forward by, the total will be the total of these two will be the total number of steps in the escalator, right?
Right.
There is a special angle. I mean, if it is like you're moving against the motion of the escalator. So it's like if the escalator is going downwards and you're moving upwards. So you have to obviously be faster than the escalator, otherwise you'll never reach the top. So in that case, whatever distance you have moved minus the distance the escalator pushed you back should be equal to the number of steps of the escalator, right?
Right.
So it is very similar to upstream downstream idea when it comes to escalator. But usually in escalator problems, because it's not a very complicated idea ever. So even in upstream downstream, you typically use the board speed as v and the reverse speed as r, something like that, right, to solve it.
Okay.
So even in escalator problems, I prefer to suggest that only until unless it's a very easy one. So in this case, let's get into the question first. So Moody takes, I like this name, Moody takes 30 seconds to finish riding an escalator. If he walks on it at his normal speed in the same direction implying whichever direction the escalator is moving, Moody is also moving in that direction. So Moody is not stationary, is also walking on it, but then moving in the same direction as the escalator. So whatever number of steps Moody takes plus whatever number of steps the escalator takes should be equivalent to the total number of steps in the escalator.
Right.
Okay. Now it says next that he takes 20 seconds to finish riding the escalator if he walks at twice his normal speed in the same direction. So remember, Moody's speed is doubling. So if previously Moody is taking 5 steps per second, now Moody is taking 10 steps per second, right? It will be very fast, but I'm just saying something like that, right? But the escalator speed is not changing. It says finish riding the escalator, right? So the same escalator. So the escalator speed is not changing, just Moody speed is changing, and hence the time is reducing or something. Now, these two can be related very easily if I assume the speed of Moody as the speed of escalator as something. Don't worry about it, two variable single equation. We don't actually have to solve for the equations. We'll just find the relationship. I'll come back to that. But let us look at what we are looking for. So the question says if Moody decides to stand still on the escalator, then the time in seconds needed to finish riding the escalator. So if Moody is not moving, then how much time the escalator will alone take it to the top, something like that, right?
Right. Correct.
So let us get into it. So what I'm going to do is, to begin with, I'm going to assume the speed of Moody to be m steps per second, and the speed of the escalator to be e, again, steps per second. Okay. So I'm just going to assume the speeds to be m and e, but steps per second, because when it comes to escalator, it is not about kilometers and stuff like that. You can, it's the same thing, but then steps makes a little more sense, right? Because we are just covering certain number of steps. So in the first scenario, what happens? So Moody is moving along with the escalator with a speed of m. So together they will move m plus e effectively. And in 30 seconds, it reaches the top, meaning the total number of steps in the escalator should be this much. I mean, n indicating the number of steps in the escalator. So n must be equal to number of steps in the escalator should be m plus e into 30. Right. In the second scenario, Moody doubles the speed, right? Twice his normal speed, but E remains E. So now Moody is walking with a speed of 2m steps per second. The escalator pushes forward by E, and this in 20 seconds leads to reaching the top. So n should be equal to 2m plus E into 20. Now, as I mentioned earlier, we don't actually have to solve for m and e. What I'm going to do is, using these two, I'm going to find a relationship between m and e. And using that relationship, I'm going to assume a set of value for m and e which satisfies that relationship. That's it. So accordingly, I'll get the value of n, and using the respective value of m and e, I can figure out whatever I need to. So let's get into it. So just you can do a lot of ways. I mean, I'm just simply expanding and stuff. So we have 30e out here and 20e out here. So to the left hand side, you'll get 10e. You have 40m and you have 30m here. So taken to the right hand side, you will have 10m. So rather you have e is equal to m.
Right. Correct.
Now, a lot of ways to do this. I mean, what you can do is you can just substitute m by e and solve it. I'm just going to simplify. I'm just going to take both as 1. It really doesn't matter. I mean, you can, instead of 1, you can take x, 5, 9, 45, whatever. It really doesn't make any difference. So I'm just going to assume this to be 1 to simplify the values, that is. So accordingly, what do we get the value of n? So we have 1 plus 1 into 30. So that is 60, right?
Right.
So what do we know? So if I assume that, I mean, this is not an assumption. This is an inference. So e is equal to m. So these two speeds are equal. So going by this relation, if I assume that both e and m are 1 step per second, then n should be, the number of steps should be 60 steps. That is what we obtained, right? Now, if Moody is standing still, then basically the escalator is pushing it forward, right? So it has 60 steps to climb, and the escalator will push with a speed of 1 step per second. So the time will be 60 seconds. That is what we are looking for. So that is the answer for this problem. That's it from my end.
Nice. Interesting one. Thank you so much, sir, for this question.
Thank you, everybody. Thank you, Ashar.
Thanks, everyone, for joining in.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.